Welcome to this P1 presentation on energy efficiency from the OCR Gateway GCSE. By the end of this session you should be able to do the following 5 things. Firstly, describe the difference between useful and wasted energy. Secondly, explain what efficiency of an appliance is. Thirdly, you should be able to draw Sankey diagrams to show energy efficiency. Fourthly, calculate the efficiency of an appliance. And finally, rearrange the efficiency calculation. Right, there are 2 key words that you're going to need during this presentation. They are Sankey diagram and efficiency. Take a minute to pause this slide and see if you can write a definition of these 2 key words. Now you've had a chance to pause the slide and write a definition, let's actually look at the proper definitions of these words. Right, firstly you've got a Sankey diagram. This is a diagram that shows all the energy transfers taking place in a device, and we'll see these shortly. And efficiency is the percentage of energy transferred by a device that is useful. Okay, it's this idea of usefulness that we'll be exploring a bit later on. Obviously we need to be able to define useful and wasted energy before we're able to draw Sankey diagrams or make the calculation. Right, so here's a TV, and when you transfer energy from one form into another, we only get some of it coming out in the form that we wanted. So we put electricity into the TV, we want light and sound, and this heat is wasted because that is any energy that doesn't become what we need it to be. So we don't need heat energy to be produced. We need the light so we can see the picture, we need the sound so we can hear what's being said, but the heat is being wasted. So these 2 up here are useful energy and this one is wasted. So we're firstly going to look at a comparison between the useful and wasted energy between 2 similar devices. Right, on the left here we've got an energy saving bulb, and on the right here we've got a traditional filament lamp. So let's look at what the Sankey diagrams would look like for those 2 bulbs. Right, this is the one from the right hand side, this is the filament bulb, this is the traditional style bulb. So it's giving you a value of energy as an example. It's not saying that all bulbs use 100 joules of energy, but in this example it does. So 100 joules of electrical energy was put in, of which that only 10 joules of that actually becomes light energy. Those old style bulbs are very, very inefficient because clearly the clue's in the name, it's a light bulb, so we want the light out. So heat is the wasted energy. But if you look at the difference between these 2, only 10 joules out of that 100 joules become light, whereas 90 joules of that 100 joules become heat, so that would be wasted. So this bit here is the useful energy, because that's what we want, and this bit here is the wasted energy. So now we're going to compare this to the one for an LED bulb. Right, so here's an LED bulb. In this situation, they're giving it the same amount of electrical energy to begin with, but this time you want to look at the difference. 75 joules out of that 100 joules is being converted to light energy. Don't forget, that's the useful stuff. 25 joules is being converted as heat. That's the wasted stuff. And if you look in both cases, it's the size of the arrow here which gives you an indication as to the size of the amount of energy. So all of this block here, that's 100 joules worth. So that 100 joules there is being split down. So a quarter of it is coming down here and 3/4 of it is coming this way. So we'll look at these arrows, these Sankey diagrams side by side. Right, this should give you a clearer indication of the difference between them. Same amount of energy coming in here because the arrow's the same size, whereas you've got a very small arrow here compared to a very big arrow here. So this small arrow for light energy for filament bulb is 10 joules, whereas this larger arrow here is 75 joules. So if you were asked what the efficiency of that bulb is, you could give the following definition. The efficiency of the light bulb is the percentage of the energy that's given as electrical energy that is converted to light. Right, now it's time to have a look at the calculation of this so you're able to calculate energy efficiency. Right, we've seen this equation before, and this is the energy efficiency equation, so let's quickly run through it. So the efficiency equation is the useful energy output divided by the total energy input. Now, in this case, this was from a power station, and so the output we wanted was the electricity, and the input energy was the fuel burned, or the coal. If we went back to our light bulb situation, our useful energy output could be the light, and the total energy input, that's going to be the electricity. So you need to look in each individual case as to what the useful energy output is and the total energy input. Clearly you might get a situation where they tell you the amount of wasted energy, but if they give you the total energy input and they give you the wasted energy, if you subtract the wasted energy from the total energy, that's going to give you that useful energy output. As with most things in physics with these calculations, you can put into a triangle, and let's have a look at that now. Right, here's the triangle. You have useful energy out at the top, you've got the device efficiency here, and the total energy in. The one thing you've got to watch out for on this is whether they've given you the information in joules or as a percentage for the device efficiency. Now, if they've given you it in joules, all you've got to do is the normal equation. So you do the useful energy out divided by the total energy in. If they give you it as a percentage, then you need to deal with that by dividing it by 100 if you're going to calculate either the useful energy out or the total energy in as the subject. Right, so let's give a quick example. So here's a device, there's 100 joules energy input and 40 joules coming out as useful. So stop this slide for a couple of seconds and I want you to work out the efficiency of the device. You may need to go back to the triangle to get the previous equation. So now you've had a chance to stop this and do the calculation, you'll see it's very simple. The efficiency is the useful energy output, which is that 40, and you divide that by the total energy input here, and then you multiply it by 100. So in this case it's quite easy because you're dividing by 100 for the energy input and then you're multiplying by 100 to give it as a percentage. So it's 40%. Right, it's now your favourite part of these sessions, it's question time. So we've divided these up depending on the difficulty of the questions. So you've either got questions up here which are E grade, you've then got questions that are C grade, and then you've got questions that are A star grade. I want you to work through them all, so let's look at the first one. Right, so take a couple of seconds, I want you to write a definition. So what does a Sankey diagram show? So pause this slide and then in a couple of seconds, once you've written your definition, we'll have a look at the answer. You've had your chance to write your answer now, so let's have a look at what a Sankey diagram is. A Sankey diagram shows the energy transfers made by an appliance. That was one of our key words right back at the beginning. So I don't see anyone having any problems with that. So if you can do that, well done, you're grade E. But let's face it, that's not that tricky for you guys. So we want you to get up to C and A star level. So let's look at the C grade question. Right, this is in two parts. A kettle is supplied with 500 kilojoules of electrical energy. It transfers 99 kilojoules to the kettle itself and its surroundings as heat energy, and 1 kilojoule is transferred into sound energy. The rest of the energy is transferred into the water as heat energy. So you need to calculate the efficiency of the kettle, and you need to work out how you can make the kettle more efficient. So pause this slide, work out the efficiency, and then come up with a reasonable suggestion as how you can make the kettle more efficient. Right, you've had your chance to work it out. Let's have a look at part. So you go back to that original equation. Efficiency is useful energy out divided by total energy in times 100. So we know that you're being supplied with 500 kilojoules. That's your total energy input. If you add together the two wasted energies here, you've got 99 and 1, so that gives you 100. That's the wasted energy. And if you remember early on, I said if you take the wasted energy away from the total energy, that gives you the useful energy. So we knew we had 500, so 500 minus 100, that's 400. 400 divided by 500, then multiplied by 100. So that gives you an efficiency for this kettle of 80%. That sort of question would probably be worth 3 marks. The second part, how could you make the kettle more efficient? So if you haven't done that, now's the chance to pause this and take a couple of seconds to work out how you can make the kettle more efficient. Right, you've done that now, so let's have a look. Right, well, I've suggested that you might want to insulate the walls of the kettle. Quite simply, you need to reduce the amount of energy that's being wasted. So you either need to reduce the amount of energy that's being transferred to the kettle itself, or you need to reduce the amount being transferred into sound energy. So by reducing one of those two, it means more of the energy that you're providing is being turned into heat energy. Right, if you've managed to do those bits, you should now be around the C grade level. Let's have a look at the tricky stuff at A star. Right, so you've got a halogen light bulb. It's got an efficiency of 12%. It transfers 30 joules into light energy. You need to do three things. Firstly, calculate the total energy input. Secondly, work out how much energy is wasted. And thirdly, draw a Sankey diagram for this light bulb. So pause this slide. I think this will probably take you about 4 minutes. So pause the slide and try and do the calculations, and then in a few minutes we'll come back and we'll look at the answers. Right, you've had a chance to do that now, so let's have a look at 3. Okay, so this is A. We still start with that equation, and this time we need to rearrange it to make the total energy input the subject, because this is what it's asked us to do. So the total energy input is the useful energy output divided by the efficiency multiplied by 100. So we know that the useful energy output is 30 because it tells us that 30 joules is transferred into light energy, and it being a light bulb, we know that the light is the useful energy. It's told us the efficiency, which is 12%, so we've got 30 divided by 12, and we multiply that by 100, and that gives us a total energy input of 250 joules. So well done if you got that. You're on your way to getting an A star. That's really the hard bit of this question. The second bit is how much energy is wasted. So again, if you've not managed this already, pause it. Now you've got the answer, because if you didn't get this answer to start with, you're going to struggle to do question B. So now you've got the answer, which is 250 joules. Let's see if you can work out how much energy is wasted. Right, now you've had a chance to do it. Right, so the wasted energy, you take the total energy and you subtract the useful energy. So for part A, we calculated that the total energy was 250 joules, and we know that the useful energy is 30 joules because that's the light energy. So 250 minus 30 gives you 220 joules. So you've now successfully done A and B, and let's see if we can draw a Sankey diagram for this light bulb. Right, here is your Sankey diagram. We know that the useful was 12%, which is 30 joules. So that must mean that 88% is wasted. So this 220 here is 88%. So you put in 250, and that block has been divided in two. So 30 joules has gone this way, and 220 joules has gone that way. So if you've managed to draw that, well done. And if you've got all three bits, brilliant, you're well on your way to that A star. So let's see what we should have now be able to do now we've reached the end of this session. Okay, you were told at the start that there were 5 things you ought to be able to do. That's describe the difference between useful and wasted energy, explain what the efficiency of an appliance is, draw Sankey diagrams to show energy efficiency, calculate the efficiency of an appliance, and rearrange the efficiency equation. And those questions there at E, C and A star level have given you an opportunity to prove whether you are able to do that. And of course, now we get to your favourite slide. We want to know what's still going to come in this series. So the next 2 sessions in this P1 series are going to be on waves, how we draw them and what they look like, and then specific waves in the form of the electromagnetic spectrum. So I look forward to you doing those sessions in the future and getting those A star grades that you really deserve. So well done, and I'll see you next time.